Yeah, good morning once again, children. Am I audible? I've shared my screen. Yeah, hi. I've shared my screen. Visible, right, children?
Yes, ma'am.
Yeah, okay. So let me just tell you what congruent triangles mean, and you will tell me the different congruence criteria. Okay, so before that, name the parts of a triangle. How many parts does a triangle have, children? A triangle has dash parts. 6 parts, namely 3 sides and the 3 interior angles. And the 3 interior angles. So a triangle has 6 parts, 3 sides and the 3 interior angles. 3 plus 3, 6. Yeah. So 2 triangles are said to be congruent. See, congruence means equal. Equal in every aspect. Congruence means identical. Equal, identical. One triangle looks just like the other one. They're identical in every aspect. Their angles, corresponding angles are equal, corresponding sides are equal. So if you have the cutouts of the 2 triangles, okay, so when 2 triangles are congruent, if you have paper cutouts of the 2 triangles, if you place one triangle over the other in a particular way, they will coincide. Okay, so see, supposing this triangle and this triangle, they are congruent. Okay, these 2 triangles, okay, say they're identical, they're congruent. Now, if you place, I call this triangle 2 and this one triangle 1. If I place triangle 2 over triangle 1 or 1 over 2, the top triangle will cover the bottom triangle completely. The top triangle will completely cover the bottom triangle. But I should place it in a particular way. Now, supposing I just bring 2 as it is and I put it on triangle 1, then it look like this. If I just drag 2 and put it on 1, it will look like this. They don't coincide. So you should rotate it and place it in a particular way. Only when you place it in a particular way, they'll coincide. Simply if you place, now you know that 2 triangles are congruent, or you have 2 identical triangles with you, and you simply place them one over the other in some way, and they don't coincide. So then you cannot say, no, they don't coincide, so they are not congruent. You must rotate the triangle and place it in a particular way. So when the 2 triangles are congruent, when you place one triangle over the other in a particular way, then they will coincide. They will coincide. So now, supposing triangle 1 is congruent to triangle 2, they are identical triangles. But you just drag 2 and place it over 1 like this. See, they don't coincide. So you should rotate 2. You must rotate this triangle 2. Rotate it. And then if you try to place it over 1, it'll exactly sit over 1 like this. So it'll exactly, the sides of triangle 2 will sit on the sides of triangle 1. Okay, so 2 triangles are said to be congruent if their corresponding sides are equal and their corresponding angles are also equal. These are the 6 parts of a triangle, 3 sides and 3 angles. If all these 6 parts are equal, these 6 parts of one triangle equal to these 6 parts of the other triangle. Every triangle has 6 parts, 3 sides, 3 angles. So if these 6 parts of one triangle are equal to the 6 parts of the other triangle, then the two triangles are congruent. So congruence is simply being identical. One triangle looks exactly like the other one in every aspect. So two triangles are said to be congruent if okay. So now we have 5 congruence criteria. Criterion is singular, criteria is plural. Criterion. Am I right? Criterion, yeah. Criteria. This is singular. This is singular, this is plural. Criteria is plural. So we have 5 congruence criteria. Now, why congruence criteria? What are they? And why congruence criteria? So when you have two triangles, with some information known about the two triangles, so you may not always know all the 6 parts of both the triangles. You might have limited information. Now, supposing you have to compare the 6 parts of one triangle with the 6 parts of the other triangle, you should always have that information. All the information you must have. So now and you have to compare. Now, congruence criteria simplifies our job. It simplifies our job. In the sense, you don't have to check for all the 6 parts of one triangle with the 6 parts of the other triangle. You can check some specified 3 parts of one triangle with the corresponding 3 parts of the other triangle. Not 6. You can just check the congruence criteria. They make our job easier. Instead of comparing the 6 parts of the two triangles, you can compare 3 parts of one triangle with the corresponding 3 parts of the other triangle. And with this, you can establish congruency. If they're congruent, you can say they're congruent, else not. Okay. So let's list the congruence criteria. So we have SSS. SSS, when you say SSS congruence criterion, because when you say SSS, that is one thing. So criterion, SSS congruence criterion, SAS congruence criterion, ASA congruence criterion. Then tell me, complete. Yeah, the last one.
RHS, miss.
RHS. So SSS, SAS, ASA, AAS, and RHS congruence criteria. Now, clearly, RHS congruence criterion can be used only when both the triangles are right triangles, because R is right angle, H is hypotenuse, and S is some side. R right angle, H hypotenuse, and S side, some side. So RHS congruence criterion can be used to establish congruency only between two right triangles. If the two triangles are not right triangles, you cannot use RHS. Now, when two triangles are right triangles, it is not that you should use only RHS. You can use any of the other congruence criterion also. You can use any of these. It's not that when the two triangles are right triangles, you have to use RHS only to show that they are congruent. It's not like that. RHS congruence criterion can be used only if the two triangles are right triangles, but the others also can be used. When you have two right triangles, you can also show that they are congruent using SAS or SSS, you can also use this. The other congruence criteria also can be used to show that two right triangles are congruent. So what we use depends on which criterion to use, depends on the information provided to us in the question. Now, since we understood that when two triangles are congruent, you need to place the second triangle over the first one in a particular way. Only then they'll coincide. Only that way they'll coincide, not any way. So this means when you name the two triangles, you must name it in such a way that those vertices coincide. Now, for example, yeah. So now here we have two triangles, ABC and PQR, and we have information about their sides. We have no information about the angles. Now, if the congruence criteria did not exist, then you cannot show because you don't have sufficient, you don't have all the information. Right, we only know about the sides of the two triangles. So we don't have information about the angles in the two triangles. So if not for the congruence criteria, if we did not have the congruence criteria, then we cannot, maybe they are you can make the cutouts, place it one over the other and say, but without that you cannot say because we do not have any information about the angles. Because without the congruence criteria, we have to check the 6 parts of one triangle and the 6 parts of the other triangle. But we have only information about the sides. We don't have information about the angles. So in that case, you cannot show that they may not be congruent, but we cannot judge that. So with the help of the congruence rules, you can, with this limited information, you can check if the two triangles are congruent or not congruent. Okay, so what do we see in the two triangles? AB of the first triangle is equal to PR of the second triangle. AB of triangle ABC is equal to PR of triangle PQR. Then BC of triangle ABC is equal to QR of triangle PQR. And AC of triangle ABC is equal to PQ of triangle PQR. So we see that three sides of one triangle are equal to the corresponding three sides of the other triangle. So now this means the two triangles are congruent to each other and the rule is SSS because the three sides, the three sides of one triangle are equal to the corresponding three sides of the other triangle. Now comes the most important thing, the order in which you write the names of the two triangles. B, B, C, A, C. Okay. Now, to name the triangles in the correct way, I'll tell you one. See, you can name it in different ways. Okay, I'll just tell you one. Now, take up any two equalities we have mentioned. Take up any two equalities we have mentioned. Any two. Now, supposing I take AB equal to PR and BC equal to QR. Okay, so AB equal to PR. See, when I'm explaining, it takes this time, but when you do it, it doesn't take this long. You can just look at it and, write it immediately. Now, here, which is a common letter? AB, BC. AB, BC, which is the common letter B. So write it like this, A, B, B, C, like it ends with B here and it starts with B here, A, B, B, C. Similarly here, what is a common letter meaning? Which is the common vertex R here? P, R, Q, R. R is common. So see here, A, B, B, C. We have P, R. R is that common letter, right? So start with R here, R, Q. P, R, R, Q. See here, A, B, B, C, P, R, R, Q. R, P, R, R, Q. Now you know that QR, RQ both is the same, like side AB, side BA. It's the same side. Side BC, side CB. Same thing. So you can write QR as RQ. It's the same side. QR, RQ. Same. Now, so I took up these two equalities. All right. Then I write it in a particular way like this, A, B, B, C, and this is P, R, Q, R. So since R is a common letter, I write it as P, R and R, Q. Now see here, A, B, C is congruent to P, R, Q. P, R, Q. Meaning see here, A, B, B, C, notice, what is it? A, B, B, C. So A, B, C, P, R, R, Q, P, R, Q. A, B, C congruent to ABC congruent to PRQ. Or you can just take away this AB, no, B is repeating, just take it away. PR, R is repeating, take it away. So ABC congruent to PRQ. This is the order. That means if you have paper cutouts of these two triangles, you must place the triangles in such a way that the vertex A coincides with the vertex B. The vertex B coincides with R, not Q. If you place it in such a way that the vertex B coincides with Q, the two triangles, the top triangle will not cover the bottom triangle completely. Okay. See, there are exceptions. In the case of equilateral triangles, you place it in any way, they'll coincide. Okay. Because all the three sides are equal, all the three angles are equal. So equilateral triangles, you place it in any way, they will coincide. So we are talking in general. So now when you have the paper cutouts of these two triangles, you must place this second triangle over the first triangle in such a way that the vertex P coincides with vertex A, vertex R coincides with B, and vertex Q coincides with C. Only when you place it in this way, you will see that the top triangle covers or coincides with the bottom triangle. Okay, now children. So ABC is congruent. So this is the symbol for congruency is congruent to. This one stands for is congruent to. Is congruent to. Triangle ABC, triangle PRQ. Okay, when you write the symbol in the middle, triangle ABC is congruent to. Like what is this? Is equal to. Is equal to. The symbol is not equal. The symbol is equal to. A is equal to B. This one is equal to. Is congruent to. Triangle ABC is congruent to triangle PRQ. Okay, now your questions. No, my questions to you. Okay, not your questions, my questions to you. Yeah. Now, if I say for the same situation, children, same situation, if I name the first triangle as triangle CAB, then congruent to what? Tell me. If I write CAB, then how will you alter the name of the second triangle?
Triangle QPR.
Q, Bhavishya, very good. QPR, because C is Q here. C and Q are the corresponding vertices. So if you say CAB, if you say A and B, you must say Q, P, and R. Change the name of the second triangle also. So when you change the name of the first triangle, the name of the second triangle is also altered. So if you say CAB, it is QPR. QPR. Match the vertices. Match the vertices. Yeah. So we know that vertex C and Q coincide. Then CAB. Children, let me not make it so difficult. Okay. So CAB, you can see a C, A, and then B. So similarly, QPR. That's all. Now tell me if I write ACB. If I write triangle ACB, is congruent to triangle ACB, congruent to
PQR.
PQR. If you say ACB, then it will be correct. PQR. PQR. Like this. So this is about SSS congruence criterion. 3 sides of one triangle will be equal to 3 sides of the other triangle. So list out the equalities. You must say in triangle ABC and triangle PQR, AB is equal to PR, BC is equal to QR, AC is equal to PQ. Then you must write this. Therefore, the two triangles are congruent by the SSS congruence criterion. So now if you're like not sure about the order, you can use this method, what I told you. Take up any two equalities I said, because naming the triangle in the correct order is very important. You cannot just write ABC, PQR. So you can take up any other two equalities also, children. You can maybe take up these two equalities. BC is equal to QR and see a BC, no, it ends with C. C, so we'll write CA. This is BCAC, no, C is common. So BCCA you should write is equal to, here it is QR. So I should write this as RQ. Because Q is a common letter, no, so I should write RQ and then I should write QP. I'm using these two equalities. I wrote it correctly. I'm just doing it again. Okay, I'm using these two equalities, this one and this one. What's common here? C. So if I write BC, I should write CA equal to, here Q is common. So I should write RQ, QP. Now take away that common letter or the common vertex, you know, this here C and Q. So BCA, triangle BCA is congruent to triangle RQP. RQP. So you can see here BCA, RQP. BCA, RQP. Okay, so don't go wrong in naming the triangles in the correct order. That's about SSS. Next, SAS. SAS, children. Okay, so SAS basically is two sides and the included angle. Now we know that an angle has two arms. An angle has two arms. Okay, see, when we mark an angle like this is say 45 degrees. See, these are the two arms. These are the two arms of the angle. All right. So when you're using SAS, SAS meaning two sides and the included angle. So look at the angle first, 85 degrees, 85 degrees here. Now for this 85 degrees, which are the arms of this angle? AB and AC. AB and AC. Angle 85 degrees here. The arms of this angle are AB and AC. And here, the arms of the angle here, 85 degrees, are NO and NM. So if you're using SAS, you must be making use of these sides, not any other, so these two sides will not be in picture. Just listen to me. I'll tell you something else later. You'll understand better. So when you're using SAS, you will be using one angle and the arms of those angles. Like one angle of the first triangle is equal to one angle of the second triangle, right? That's one information. And then the arms of the angle in the first triangle should be equal to the arms of the angle in the second triangle. Okay. So in triangle ABC and triangle MNO, here you can write any order. Here you can write any order. Here you're not writing congruency, no, you're just naming the two triangles. So you can name them in any order, ABC, ONM, whatever. When you use the symbol, then you should name it in the correct order. So in triangle ABC and triangle MNO, one. And now see, when once you know everything about this chapter, you as soon as you see the figures, you have to use SAS. So list out the equalities in the same order, just for I think discipline. Just write it in that order. See, it's like when you're getting ready to school in a hurry, you don't want to wear your shoes and then have breakfast, right? We normally don't do that. We don't eat with our shoes, footwear on. In some restaurants, I see people, they remove their footwear when they eat. So that's the respect we offer to food, right? So you don't want to, even if you're in a hurry, you don't want to wear your shoes and then go to the table, and eat your food. So you want to do it in a particular order. Even if you're in a hurry, you want to have your food first and then put on your shoes. So like that, SAS, you can write it in any order. So again, we'll maintain some discipline. We'll write it in this order, SAS. We'll write the equal sides first, equal angles, and then equal sides. Even if you change the order, that's okay. That's okay, but keeping discipline as a priority, we'll write it in this order. But maybe later when I forget to use it, please remind me about the discipline in case I forget. All right, so now essay. So we'll mention the side first. So we'll first mention the side, then angle, and then side. Okay, so side. AB of the triangle ABC is equal to what of the second triangle? Tell me. AB of the first triangle is equal to?
ON.
ON. You can write ON, NO. So don't be nervous. Don't be scared. Should I write ON? Should I write NO? Both are the same, right? Any order, anything. NO or ON, whatever. Okay, this is given. You must write the reason also. Sometimes you can write is equal to 5 centimeters, but don't have to. Just write given. You'll have to give a reason. Okay, give a reason, given. Then angle. So angle BAC is equal to angle. Tell me, is equal to angle?
MNO, ma'am.
MNO.
MNO. Yeah, that also is, correct. That also is given. Then next.
AC is equal to
AC is equal to MN.
Yeah, AC is equal to MN or NM, whatever, is equal to MN. That's also given. So we've listed the information, we have listed the equalities in this order, SAS. And you can see that for this angle, this angle BAC, for this angle, these are the two arms. These are the two arms. And you can see, you can see the angle here and its arms here. This is one arm, this is the other arm. And for this angle MNO, this is one arm, this is the other arm. So when you're using SAS, the angle which is equal, one angle of the first triangle is equal to one angle of the second triangle. Then in the first triangle, you must be mentioning about the arms of this angle. And in the second triangle, you must be mentioning about the arms of this angle. Okay, so clearly for this angle 85 degrees, AB and AC are the arms. And for this angle, NO and NM are the arms. And that's what we have mentioned here. See here, for BAC, we have mentioned the arms AB and AC here. And for the other, the second triangle, the arms NO and MN. They should be equal. The arms of one triangle should be equal to the arms. That is arms, I'm saying the arms of that angle. So the arms of the first triangle should be equal to the corresponding arms of the second triangle. That only makes SAS. So now how to name the triangles in the correct order? So same thing you can use. You can, make use of these two equalities we have. We have the equalities AB and NO, and then AC and MN. These are the two equalities we have here. Equalities of the sides, I'm saying. AB is equal to NO and AC is equal to MN. So the common letter is A. So BA, AC. And in the second one, the common letter is N. So ON, NM. Right? AB as BA, AC as AC itself, and then NO as ON, and MN as NM, because N is common. So now you can just remove that common letter. So the order is, therefore, triangle BAC is congruent to triangle. If you say BAC, it is ONM by the SAS congruence criterion. So like this, the two triangles are congruent by the so see, again, we don't have all the information. We have only three things of the first triangle and similar things of the second triangle. We don't have all the 6 parts of the two triangles. Still, we are able to establish congruency with the help of the congruence criterion. So now that the two triangles are congruent, children, now that the two triangles are congruent, you have proved that they are identical. These two triangles are identical. That is, if you place, you must have triangle, the first triangle like this, BAC. Now the second triangle, you should place it over the first one so that the vertex O coincides with vertex B, the vertex N coincides with A, and the vertex M coincides with C. When you place the second triangle over the first one, by coinciding the corresponding vertices, then the second one will completely cover the first triangle. The sides will overlap. The sides, their boundaries will sit on one another. Their boundaries will coincide. The boundaries of the two triangles will coincide. See, covering it can be like this also. Now, if it's one small triangle and one big triangle, that also will cover. If you have one small triangle and a big one, you can place the big triangle over the small one and it will cover. It's not like that. So the boundaries, their perimeters, their boundaries will coincide. So this is about using SAS. So you cannot go wrong in naming the triangles in the correct order. You cannot go wrong. It's very difficult to go wrong. So now BAC. Now if supposing I write CBA, children, triangle CBA, then it's congruent to triangle. If you say CBA, then Right. Children, if I say, yeah, tell me.
MON, ma'am.
MON, very good. MON. If you say CBA, if you say C, B, and A, you must say MON. MON. So now that the two triangles are congruent, that means they're identical. They're identical. Now their remaining corresponding parts also are equal. I forgot to say that in the first one when we showed that the two triangles are congruent by SSS. I forgot to mention that, children. Sorry. So same thing applies there. So now the remaining things, the remaining sides, that is the lengths which we don't know or the angles which are not known to us, the corresponding angles and the corresponding sides are also equal because now the triangles are identical. We prove that they are identicals. So once the triangles are congruent, once you prove that the triangles are congruent, their remaining unknown corresponding parts also will be equal. The other unknown corresponding parts also will be equal. So how do you identify that? See here, angle C is equal to angle M. Angle C is equal to angle M, which is angle C, this one. This one is angle C, will be equal to angle M, will be equal to M. Angle B is equal to angle O. B is equal to O. Angle B is equal to angle O. Angle A is equal to angle N. Yeah, that we already had. A is equal to N, we already had. We only knew A is equal to N. We didn't know about the others. Now that the triangles are congruent, their remaining unknown corresponding parts will be equal, will also be equal. Then about the sides, side CB is equal to MO. CB, MO. See the CB, the side CB is equal to MO. Because they're congruent. Now they're congruent. So their corresponding sides and angles will be equal. So CB, side CB is equal to side MO. Then side BA is equal to ON. BA, that we already knew. BA is equal to ON, we already knew that. Meaning that was already given to us. And then CA is equal to MN. CA, MN also given to us. So what is new? BC is equal to MO, we didn't know. So now that they are congruent, BC is equal to MO. You cannot find the length of the side. How much is the length of BC or MO? That we cannot find. But we know that they're equal. And about the angles also, the corresponding angles are equal. But you cannot find their measure. Because we only know one angle, right? We know only one angle. So you cannot find, using angle sum property, you cannot find the remaining two angles. You cannot find the length of the sides or the measure of the angles, but they are equal, is what we can say. So this is about essays. So when two triangles are congruent, so you have just the needed information, like 3 parts of one triangle equal to the 3 corresponding parts of the other triangle. So you use the relevant criterion and you show that they are congruent. Once you prove they are congruent, using the order in which you have named the triangles, you can write the remaining, the unknown parts. We didn't know the measures of some sides and some angles. So using that's called CPCT. Corresponding parts of congruent triangles are also congruent. Corresponding, see now, normally in schools, I think CPCT. CPCT-C means corresponding parts of congruent triangles are congruent, meaning are congruent, meaning equal. Are congruent, meaning equal. Corresponding parts of congruent triangles are congruent. You can just write CPCT also. CPCT meaning corresponding parts of congruent triangles are congruent. CPCT-C. That's the reason we give. So when you write, so here when you write CA, not CA, what is CB, no? Yeah. In our example, if you write CB is equal to MO, CB is equal to MO. No, it's not given, no, that CB is equal to MO. But we have proved that the triangles are congruent. So now CB is equal to MO. So what is the reason you will write? CP, CT. Corresponding parts. Because the triangles are congruent, their corresponding parts are equal. Now CP, CT cannot be used here itself. When you're writing AB is equal to NO, you cannot write CP, CT. CP, CT is a reason that can be given after showing that the triangles are congruent. Now this triangle is congruent to this triangle. After that, you can write therefore this side is equal to this side CPCT, or this angle is equal to this angle CPCT. CPCT cannot be used here. Before proving that the two triangles are congruent, you cannot use that reason CPCT. Once you show that two triangles are congruent, then you can write one angle or one side is equal to angle or side of the other triangle, reason CPCT. Corresponding parts of congruent triangles are congruent. That is, what is it? Essays. Now, let me just make it a little faster now that you've understood. So now the next one is AAS. AAS. So two angles. So if this angle is equal to this angle, then say this angle is equal to this angle. Okay, let me say ASA first. Both are the same. ASA, AAS. Okay, and this side is equal to this side. Let me mark this as MNO XYZ. Okay, so when you have information of this kind in two triangles, now this angle is equal to this angle is given. This angle is equal to this angle is given, and this side is equal to this side. Now you can see that this side is contained by these two angles. This side, see now this is angle M, this is angle O, this one is angle M, this is angle O, and this is side MO. You can see MO, angle M, angle O, side MO. So if you're talking about angle M and angle O, then MO is the included side. And here if you're talking about angle X and angle Z, XZ is the XZ is the included side. So here when we say ASA, it is about two angles and the included side. Like SAS is angle, and this angle is contained by these two sides. That is two sides and included angle. Two sides and included angle. These two sides will be the arms of this angle. SAS. Two sides and the included angle. So for this angle, these two sides will be the arms. For this angle, these two sides should be the arms. Now this is two angles and the included side. So angle M, angle O. So MO is the included side. Angle X, angle Z. So XZ is the included side. So you must list this information. Angle M is equal to angle X, angle O is equal to angle Z, and MO. Oh, okay, see, I forgot the discipline. So what's it ordered? ASA. Okay, so you should say angle M is equal to angle X, then MO is equal to XZ, and angle O is equal to angle Z. So two angles and the included side. Side, this is side. So therefore, the two triangles are congruent by the ASA congruence criterion. Now, when it is ASA, it's more easy to name, you know. See, if you name the triangle, if you name the first triangle as MON, so you know that angle M is equal to angle X. You know that M is equal to X. So if you write M first, you should write X first. So order triangle MON is congruent to triangle. So you know that the vertex the angle M is equal to angle X. So if you write vertex M first, you should write the vertex X first. Then you know angle O is equal to angle Z. So if you write O in the second place, you must write Z here. And then the third vertex, Y. Or if you name the first triangle as triangle NOM is congruent to triangle. If you write N is that angle which we don't know in these two meaning in the first triangle. So if you write this angle N first, then you must write Y here. If you write N here, you should write Y in the second triangle. Then if you write O in the first triangle, then it is Z in the second triangle. And then the third letter, third vertex, YZ, X. So this is ASA, two angles and the included side. So if you say angle M, angle O, MO, angle X, angle Z, XZ is included side. So again, once you say that the two triangles are congruent, now you can find the other equal parts also. The other equal parts. NO, side NO is equal to side YZ. NO is equal to YZ. NO is equal to YZ. CPCT. Now we proved that the two triangles are congruent by ASA rule. Why we use ASA is because information given. Now for this triangle, you cannot use SSS. Meaning for the information provided here, you cannot use SSS. So depending on the information provided, you'll have to select the congruence rule. Sometimes, we have more information. So you can use more than one rule. So you can choose any rule. Sometimes we have more than, the needed information. In that case, you can use any rule. But here, in this example, you can show that the triangles are congruent only using ASA. You can also use AS for the same information. I'll tell you how. So coming back to this, so now we proved that the two triangles are congruent by ASA congruence rule. So now CPCT, NO is equal to YZ. NO is equal to YZ. We didn't know that. So now, because they are congruent, these are the corresponding sides. NO corresponds to YZ. Then OM is equal to ZX. OM that we already knew, that was given already. Okay, OM and XZ already given. Okay, then NM is equal to YX. NM is equal to YX. CPCT. Then this angle N is equal to angle Y. CPCT. N is equal to Y. Angle N is equal to angle Y. Angle N is equal to angle Y. CPCT. Now, the difference between ASA and AAS is that in the first one, it is two angles on the included side. But in this one, it is two angles on some other side, not the included side. ASA is two angles and the included side. I told you what is included side. If you say angle M, angle O, then the included side is MO. If you say angle X and angle Z, then angle X and angle Z include the side XZ. So ASA is two angles and the included side. AAS is two angles and some other side, not the included side. See, included side is one side. Sorry. You can't see my screen, right? Yeah, now it's back. Can you see the screen, children?
Yes, ma'am. Yes, ma'am.
Yeah, okay.
Yes, ma'am.
So, yeah, thank you. No, I forgot what I was saying. Yeah, so included side is one side. Now, a triangle has three sides, so leave that included side. There are remaining two sides, right? That's what it is. So if it is if it is AAS, it is two angles and some other side. Those two sides, those two remaining sides, one of those sides it will be. So we'll see that rule now. See now, supposing they ask you, no information is given. No information is given. Now tell me, are these two triangles congruent? Can you say, are these two triangles congruent? Nothing is given. No information is given. If nothing is given, can we say that the two triangles are congruent? What happened? If no information is given, can you say that the triangles are congruent or not? You don't have the cutouts. You don't have the paper cutouts. You just what you just see. So on the screen you see two triangles with no information. Can you say if they're congruent or not congruent? Is the question.
No, ma'am.
We can't say. Meaning, see, you're saying we can't say, right?
We can't say if it's congruent.
Can we say? We can't say. We can't say. Which option are you saying? One or two? Yes, we can say. No, we can't say. Okay, let me write like that. Shit. Yes, we can say. No, we can't say. Which option? You can see the triangles. You can see the triangles. My question is, no information is given about the two triangles. Can you say that they are congruent or not congruent? Yes, we can. No, we can't.
Ma'am, no, we can't say, ma'am.
No, we can't say. Okay. Anybody? Yes, we can. Then you should say how. What is that invisible rule you can use? Anybody? Yes, we can. No, understand my question. Then you shouldn't say you didn't make us understand your question this way. I'm saying you see the triangles. You can see two triangles. No information is given. My question is, can you say that these two triangles are yes, these two triangles are congruent? No, these two triangles are not congruent. Or you can't say anything. No, we can't say, nothing is given, so we can't say anything. Okay, so all of you are saying, since nothing is given, we can't say, correct? Okay. So I'm saying they are not congruent. No. The answer to this question is no. The two triangles are not congruent. The two triangles are not congruent. Not congruent. If you're given these two figures, okay, in your exam, and you have options, okay, triangle ABC, the two triangles are congruent. The two triangles are congruent is one option. The two triangles are not congruent is the other option. No, we can't say because no information is given. We can't say. It's one option. Okay, these three options. That's all. These two diagrams are given and the options are, yes, the triangles are congruent. The second option, no, the triangles are not congruent. And the third option is, no, we can't say. Because nothing is given, how can I say? So I can't say. Maybe, may not be, I don't know. But the correct answer is no, the two triangles are not congruent is the correct answer, because it's very clear that ABC is smaller than PQR. ABC is a little triangle. PQR is bigger than ABC. So how can they be congruent? Congruence means identical triangles. One will look just like the other. And ABC and PQR, you can see on the face of it, ABC is smaller than PQR. So even if information is given, the triangles will not be congruent. Yeah, I'm sure you all understood. So even if sometimes an information is not given, but you can see that one triangle is small, the other is big. That is, one triangle is bigger than the other triangle. Then you can clearly say that the two triangles are not congruent to each other. In this case also, supposing you have a right triangle. You have a right triangle. And another triangle is an isosceles or an equilateral triangle. No information is given. Can we say that these two triangles are congruent or not congruent? Okay. So these two triangles are not congruent to each other. They cannot be congruent to each other because because here there's 90. In this triangle, there's no 90 degrees. It's all 60, 60, 60, 60. You can see that angles. When the two triangles are congruent, angles of one triangle equal to corresponding angles of the other triangle. In the right triangle, there is 190 degrees. But in equilateral, there is no 90 degrees at all. So a right triangle and an equilateral triangle cannot be congruent. A right triangle and an equilateral triangle cannot be congruent. Okay. Now talking about AAS. AAS. So now for angle A, oh no, I'm talking about AAS, right? I'm sorry. I'm talking about AAS. Yes. All right. So now triangle ABC, triangle PQR, you can see the information. Angle A is equal to angle P and angle C is equal to angle Q. Now in the first triangle, when you say angle A and angle C, the included side is AC. In the second triangle, when you say angle P and angle Q, the included side is PQ. But we have no information about AC or PQ. We don't know if AC is equal to PQ. We don't know because it's not given. In the first triangle, we have angles 60 and 40, angle A and angle C, 60 and 40. So angle A, angle C, meaning the included side. The side included by these two angles is AC. And for the second triangle, the side included by the two angles is PQ. This is the side included. But we don't know if AC is equal to PQ. Okay. So angle A of the first triangle is equal to angle P of the second triangle. Angle C of the first triangle is equal to angle Q of the second triangle. But AC equal to PQ, we don't know. That's only the included side. AC, PQ included side, but that we don't know. So we are going to write some other side. What is that some other side? AB of the first triangle is equal to QR of the second triangle. So this is what is AAS. Two angles and some other side, not the included side. If you're writing about two angles and not about the included side, you're writing about some other side. That is AAS. Two angles and some other side, not the included side. Angle A is equal to angle P given. Angle angle C is equal to angle Q given. If you have to use ASA, then you should write two angles in the included side. So we've written two angles. Included side will be AC. And for the second one, PQ. But it's not given. You cannot just write AC is equal to PQ. It's not given. You cannot write AC is equal to PQ. How? It should be given to you. Now, how did we write angle A is equal to angle P? Because we can see it's marked 60, 60, so equal. Then angle C is equal to Q. Yeah, 40, 40, it's given. Now, just because we want to use ASA, we cannot simply write AC is equal to PQ. AC is equal to PQ. That's not given. But we can write AB is equal to QR. Why? Because it's marked. See here, AB is marked equal to QR is marked. So clearly AB is not the included side for these two angles, and QR is not the included side for these two angles. So here we have mentioned two angles and some other side. So here the two triangles are congruent by AAS, two angles and some other side. And the order, if you say triangle ACB is congruent to triangle, if you say ACB, you must say PQR, PQR. Because angle A is equal to angle P, angle C is equal to angle Q, and angle B is equal to angle R. That's not given, but you know, third vertex. So this is AS, two angles and some other side, not the included side. Again, same thing. Once you prove that the triangles are congruent, their corresponding sides will be, you can use CPCT and find the other equal parts. RHS. Yeah. So I'll show you how to use RHS and also to use some other property, meaning some other congruence rule in right triangles. You can also use other congruence rules for two right triangles. Depends on the information given. Okay. So here, right angle B is equal to angle P. Angle B is equal to angle P. 90 degrees because it's marked 90. 90, 90. Angle B is equal to angle P. You must write one angular side of the first triangle equal to angular side of the second triangle. You cannot write two things. You can see now, supposing you write B, angle B is equal to angle C. They are two angles of the same triangle. That is not a valid point. That's not a valid equality. Supposing also, I'm saying supposing angle B is equal to angle C. B and C are angles of the same triangle. That is not, you cannot write that equality to show that the triangles are congruent. You must write one angle or one side of the first triangle equal to one angle or side of the second triangle. Writing two sides are equal or two angles are equal of the same triangle is not a valid information. Yeah. So angle B of the first triangle is equal to angle P of the second triangle. Then AC, the hypotenuse AC of the first triangle is equal to the hypotenuse RQ of the second triangle, right angle hypotenuse RH. Right angle B is equal to angle P. Hypotenuse H. AC is equal to RQ. Why hypotenuse? Because it's opposite to the right angle. Opposite to right angle. And it's marked, it's given. AC is equal to RQ is given. Then any side, RHS, any side. There are two remaining sides, no? Other than the hypotenuse, now there are two remaining sides. Any side. So side BC of the first triangle is equal to side PR of the second triangle. Side BC is equal to PR. It's marked, it's given. See here, it's given. BC of the first triangle is equal to PR of the second triangle. Yeah. So like this RHS congruence rule, the two triangles are congruent. Now the remaining angles and the remaining sides also will be equal by CPCT. Now supposing in these two, yeah, and how to name the triangles in the correct order? Same method, children. Same method. You can use these two equalities. AC, write this as CB. And then this one as RP. Oh no, this is also QR. AC, CB, QR, RP. So triangle ACB, triangle QRP. Same way. Now, for the same two triangles, if we have information like this, now it looks small and big, ignore that. Now these are two right triangles. You want to use RHS. You want to use RHS. But you cannot use it because the hypotenuse is not given to be equal. See, you can say that I can show and all that. Don't do all, you don't have to do that. Use whatever is given. Use information given and show that they are congruent. So based on the given information, since we don't know, it's not given. It's not given that the hypotenuse AC is equal to the hypotenuse RQ. AC is the hypotenuse because it's opposite to the right angle. Here, opposite to the right angle is RQ. So it's not given that AC equals RQ. It's not given. So when you don't know, or when it's not given that the hypotenuse of the first triangle is equal to the hypotenuse of the second triangle, you cannot use RHS because RHS is right angle, hypotenuse and side. Now here hypotenuse AC and hypotenuse RQ are not given to be equal. So you cannot use RHS, though the two triangles are right triangles. The two triangles are right triangles. You want to use RHS, but you cannot use because hypotenuse equal is not given. So here you will be using SAS, two sides and the included angle. Two sides and included angle. See here, 90 degrees, 90 degrees. So angle B. For angle B, the arms are BA and BC. For angle B, the arms are BA and BC. And for angle P, the arms are PR and PQ. PR and PQ, 90 degrees. Angle P, PR, PQ. Angle B, BA and BC. So you can see that in the first triangle, AB of the first triangle is equal to PQ of the second triangle. Angle B of the first triangle is equal to angle P of the second triangle. And BC of the first triangle is equal to PR of the second triangle. Now for this angle B, these are the arms. AB and BC. AB and BC are the arms of angle B. And in the other triangle, PQ and PR. PQ and PR. PQ and PR are the arms of angle P. Are the arms of angle P. That's what makes SAS. Two sides and the included angle. So these two sides will be the arms of this angle. Okay, so like this, SAS, the two triangles are congruent. Then CPCT, you will get AC is equal to RQ. AC is equal to RQ, CPCT. Now that they are now that the two triangles are identical, they're congruent, their corresponding sides and corresponding angles will be equal, and hence AC is equal to RQ, CPCT. So here it will be triangle ABC is congruent to triangle. Tell me. Tell me the correct order, children. ABC, if I write ABC, it's congruent to?
Ma'am, PQ, ma'am.
PQ.
Ma'am, QPR.
QPR.
RPQ. Ma'am, QPR.
QPR.
Yeah, so which are the two equalities, children, here? AB is equal to PQ, and then BC is equal to PR. Now, how will we, yeah, so which one will you change here? AB, BC. AB, BC, correct. Then here, PQ, PR. Which one will you change? Which one will you alter? You will write what as what?
So A is equal to Q, B is equal to P.
No, some of you are answering, but it's not clear. Now, what changes?
A is equal to Q
AB is
and
equal to
B is
QP.
equal to P.
No, I was telling you one particular way, right?
Miss, AC is equal to QR, miss.
AC is equal to QR. What are you
Ma'am,
talking about?
Ma'am, AB is equal to QP.
Ah, who's that? Bhavishya. Yeah, that's what. See, you must understand my question. We've been talking about something, so you should understand what I'm expecting from you. So we have. Now this makes me repeat the whole thing. Why suddenly Haripranav you spoke about the hypotenuse? I don't know. See here, what we have is AB is equal to PQ is given. Angle B is equal to angle P is also given, and BC is equal to PR is given. So side, angle, side. I told you for this angle, these are the two arms, and for this angle, these are the two arms. Now to name the triangles in the correct order, let's take up the equalities we have written. We have written AB is equal to PQ, and then BC is equal to PR. Using these two equalities, let's name the triangles in the correct order. So I said AB, BC. It's like it ends with B, so you start with B here, AB, BC. So Haripranav, tell me what changes should I make here? PQPR, which is a common letter. PQPR, which is a common letter.
Miss P, Miss.
P. So how should I? Now you should tell me. I don't know what question to ask. P is the common letter. So what will you do? Yeah, somebody else tell me.
PQ as QP.
Yeah, I should write PQ as QP. Prenu. Correct? Prenu, right?
Yes, ma'am.
Yeah, Bhavishi also told me earlier, and some others also answered, but I couldn't get it clearly. Yeah, so since P is the common letter here, write PQ as QP. Then I told you just take away this one. So ABC is congruent to QPPR. QPPR. So QPR. The triangle ABC is congruent to QPR, not PQR. Only if you name this correctly, you can get the results, the remaining results. That is the results you write for CPCT correctly. If you go wrong in naming the triangles here, your CPCT results also will be wrong. No, Haripranav, I can repeat it. See, maybe I feel I'm clear, but I may not be clear to all of you. You can ask me if that part is not clear, I can repeat it.
Miss, no, Miss, is clear only, Miss.
So maybe you didn't understand what my question was, right? What I was expecting, probably you didn't understand. You're sure you understood this?
Yes,
Haripranav,
Miss.
how to name the triangles in the correct order?
Yes, Miss.
Okay. So the two equalities we have written are AB is equal to PQ, that's given, and BC is equal to PR. I only said here the common letter or the common vertex is B. So AB, BC, and just take away this B. Meaning B is common, no? So just take away one B. Then here PQ, PR, P is common. So let's write this as QP. PQ, QP, both are the same. So QP, PR, just take away this P. Now ABC. ABC is congruent to QPR. Children, do this in the rough column. Don't make the changes here. Don't make, this is our rough work. To name the triangles in the correct order, this is our rough work. Don't do all these changes here. After listing the three equalities, you have to name the triangles in the correct order, right? To do that, do this as a rough work. Don't show all this here. So like this is the order. ABC congruent to QPR, not PQR. Now you can see the hypotenuse AC. Hypotenuse AC is equal to the hypotenuse QR. See here, QR. AC, you can see QR. So these two triangles will coincide only when you place vertex, only when vertex A coincides with vertex Q, B coincides with P, and C coincides with R. So this was all about the congruence rules. So congruent triangles means identical triangles. So if you have one small and one big triangle, straight away they are not congruent. Because one is small, the other is big. How can they be? How are they identical? They're not identical. So they're not congruent triangles. So these are the 5 congruence rules: SSS, SAS, ASA, AAS, and RHS. AAA is not a valid congruence rule. AAA is not a valid congruence rule. Similarly, SSA is not a valid congruence rule. AAA is not a valid congruence criterion. SSA is also not, or ASS, whatever, ASS is not a valid congruence criterion. Let me write that. AAA, SSA or ASS, not valid congruence criteria. I can just give you one example for this one. Now consider an equilateral triangle ABC with side 5 centimeter. Equilateral, no? So all the sides are equal. Equilateral, so all sides are equal. And you know, all the angles measure 60 degrees. 60. Now we have another equilateral triangle. We have another equilateral triangle, say PQR. Sides 9 centimeter. Equilateral triangle, no? So angles will be 60 only. Even if you take a very small triangle, and if it's equilateral, the angles will measure 60 degrees. However small or big the equilateral triangle is, it's very small. Equilateral triangle, but very small or very large. The angles will measure 60 degrees. Each angle of the equilateral triangles will measure 60 degrees. So you can see here, if AAA is a valid congruence rule, then these two triangles are congruent because angle P is equal to angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R. Angles are equal. Angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R. Then that means the two triangles are congruent. But no, this one side 5 centimeters, here 9 centimeters. They are not identical. They are not identical. So you can understand why AAA is not a valid congruence rule. If AAA is a valid congruence rule, then all equilateral triangles, whether small or big, you will say that they are congruent. And you know they cannot be because they have different sizes. Congruent triangles have the same shape. Congruent triangles have the same size. Shape they'll have because both are triangles. Shape they'll have because both are triangles. So triangles have the same shape. They have 3 sides, they're closed, and they have 3 sides. So congruent triangles should have the same size. But you can see the equilateral triangles with different sides, 5 centimeters, 9 centimeters, they have different sizes. So they are not congruent because they're not identical. So this one is not a valid congruence rule. So are so are SSA and ASS. These 3 are not valid congruence rules. All right, children. So I thought we could at least start discussing the answers to the MCQs which I had shared, but I think no, it's time. So we shall continue with this in the next class on Tuesday. Attempt as much as possible. Try to go through all the questions and answer how much ever possible. We'll discuss all the answers from the beginning in the next class on Tuesday. All right, children. So that's it for today's session. Thank you so much. And thank you. I should thank each one of you for making it convenient to join the meeting. Online students, use the emoji, raise your hand. Adigamai, Hari Pranav, Abhishek, that's great. Adagamai, Hari Pranam, Abhishek, Laksha, Mritsa, Anirudhan, Anugraha. Anugraha is a very silent guest. So Anugraha is like a judge. She silently watches over me. How I teach. Am I teaching correctly? Thank you, Anugraha. And let me know your comments. Prenu, Krishna Priyan, Bhavishya, Niveda, Blessy. And who's the other one? MG. Who's MG? Meeting guest. There's one more person. I don't know who it is. All right, children. Thank you so much for joining. You may leave the call. Thank you.
Thank you, ma'am.
Thank you.
Thank you, children.
Thank you, Miss.
Thank you, ma'am.
Thank you, children.
Thank you, ma'am.
Thank you. See you.
Thank you.